Hi, I'm Riley, and I'm going to be talking to you guys about Redwood Rising and their stream restoration projects associated with the project. I'm excited to talk about it today. I've worked on this project since 2022, so it's very much kind of defined my early career, and I'm really excited about this project. Okay, so to start, I'll be giving a quick introduction on the land use history of the park. And the just general geographic locations. I'll talk a little bit on the beginning phases of restoration, especially the restoration starting back in the 80s, and then how that transitioned into Redwood Rising as we know it as a project today. I'll get into the specific project goals, and then I'll focus the implementation on just the southern half of the project in Greater Prairie Creek and daylighting channels. I'll go into our current progress so far with this landscape restoration, and then I'll end with the monitoring efforts and the assessment that's been done so far. So the overall project area is in Redwood National and State Parks. Redwood National Park was first established in 1968, but before that, two state parks, Jed Smith State Park and Prairie Creek State Park, were both protected by the state of California since the 1920s. And so the original plans were to kind of take over those parks and bring them into the National Park Service, but they instead decided to go ahead and co-manage, which is how it is still ran today. The initial national park boundaries included those two state parks and then expanded to include an additional 58,000 acres, which included a really narrow half-mile band that ran along the Redwood Creek corridor in what's often referred to as the Emerald Mile. Unfortunately, after the park was established, logging continued right up into the park boundary. And so here, if you're familiar with it, this inner river bend, which hopefully this will show up, this inner river bend here, this is Tall Trees Grove. So if you've ever done the Tall Trees Grove hike, you've hiked down to this section of Redwood Creek. But up through here is where you park and hike down through all of this really dense second growth forest. And so they were cutting right up to the park boundary and then all the way to the stream in the upstream portions of the watershed. And it was becoming pretty clear that this was severely degrading the habitat. And so that was protected by the Park Service. And so after a lot of pushing from different environmentalists, Congress mandated that USGS would do a study to see what the impacts of this logging were. And unsurprisingly, they found across a series of studies that the upstream logging was severely degrading the park. It was, obviously you guys have heard at this point of the infamous 64 flood, and it was leading to huge amounts of aggradation in the creek. So we were directly threatening fish populations in the stream with this huge amount of sediment. But the other part that really pushed Congress to start to make a change was that projections were that if it continued at that rate, that the stream would degrade so severely that Tall Trees Grove and Hyperion, which were big reasons the park was established in the first place, would potentially end up underwater, at least in larger floods, and to a degree that they thought was going to threaten these old growth stands. And so this is some pictures you guys have seen in the class, several pictures by Dave Vandemark up to this point, and those have all been in the Redwood Creek Basin. Dave Vandemark was a really awesome environmentalist. He's come and give a couple great talks at Redwood, but he went through and photographed the damage in Upper Redwood Creek. And was really instrumental along with the Sierra Club in getting the park expanded and really expanding the protections. Here you can see where they have fully just built their roads right next to the stream channel. They've cut all the way to the stream, and what was once this very famous Emerald Mile, this is just a little upstream of the Emerald Mile, was just turned pretty much gray, and that all we're having really massive amounts of sediment enter the stream. And so that is what altogether led to the expansion in 1978. And so you can see in the yellow boundaries here, this is that southern half of the park. So you can see in this big picture, it's this bottom section. All this yellow here is the original national park boundary. So that includes Prairie Creek State Park up here, and this section here where there's like Lady Bird Johnson Grove, if you've ever hiked it. All this green area was expanded, but was clear-cut for the most part at the time of expansion. They did incorporate an additional 38,000 acres of clear-cut forest, but they did also save some more old-growth stands here. And so this was pretty monumental for a couple of reasons. For one, this was the first time that the National Park Service had intentionally, or Congress had intentionally included degraded lands as part of the national park system. Before, it was very much focused on maintaining those like perfect pristine landscapes. And the other thing that they did was that they mandated that the National Park Service would create a watershed monitoring program to assess the impacts found in those 1970 studies, and that they would devise a comprehensive rehabilitation plan for the entire watershed. And so this is what really started this move towards full watershed restoration that we see today. When they first started with that watershed those watershed studies, what they found was that it was the logging roads and the stream crossings that were really contributing the most amount of sediment and were the largest issues on the landscape. Yes, there were these huge clear-cut areas, but there was such robust seed banks. It's so wet and things just grow crazy here that those were quickly becoming more stable with just vegetation regrowth. But the ways that the logging roads had altered that hill slope hydrology, they'd really disrupted those processes, and especially those road crossings were what were having these catastrophic failures. So just huge amounts of sediment entering the creeks. And so that's where they really started on that rehabilitation program, was focused on road removal and road crossing removal. When they very first started, they were afraid of repeating the mistakes of the past. And so there was a big push to treat this like a wilderness area. So we'll still have some places in the US where if you're going out and doing trail work or that kind of thing, you can't use chainsaws, you can't use any large equipment, because they want to keep those places as wild as possible. So they started with wilderness rules, with hand tools and mules, and it was pretty quickly that they figured out that that was just not going to cut it. And so they actually ended up hiring on some of the same people who had put in the roads and had been using large equipment for the forest companies to put the roads back. And so there was the beginning of the move towards using that larger equipment, more so in the late 80s and early 90s. So here's a couple of pictures of what some of those early efforts look like. So this was all in the Redwood Creek Basin. So here you can see there's a super porched culvert and this road coming around, and then in the after, they've pulled that culvert out and they've recontoured that section of the road. You'll notice here they did replanting, but they hadn't put down a lot of wood, and we'll see a lot more of that through the rest of this presentation. And that was just because this has been a big learning process. No one had ever really tried to do this before, and so every stage of this restoration, starting back in the 80s and 90s, was really been a learning curve as to what actually works. And so here we can see another picture from some of those early efforts, and there's this road coming through to begin with. They've already started the recontouring on this end, and then this is what it looks like after. And this is where they really started to use this downed wood to help to stabilize the banks, or stabilize the hill slope, so that while we have that natural regeneration, we're not having huge amounts of erosion on just due to the exposed sediments. So all of this eventually became what we know now as Redwood Rising, and I think that transition is pretty interesting. So for one, they really started to wonder about the trees. right away, there were people talking about these dense second growth stands. A lot of the second growth was reseeded with aerial seeding with seeds that were inoculated with a rodenticide. And so what that meant was that your trees are coming back incredibly dense. Um, Almost all of the seeds are germinating because nothing could eat them. And then they were a whole host of species and not necessarily all natives. And so you end up with these incredibly thick forests. But it was really, really hard to convince people, the public, regulators, that cutting within this national park was a good idea. It was decades of fight to get these lands protected from logging. And a lot of people, I think rightfully so, were really worried about it being like a wolf in sheep's clothing, that we were going to say that it was to better the environment and we were going to come and cut out all of these trees. And that would be at the cost of really losing old growth forest. And so it took a lot of science and a lot of science communication to really convince people that the right move for the true health of the forest and protecting old growth forest was going to include some thinning, because an old growth forest ranges on average from like 8 to 30 trees an acre, where the second growth forest within the park ranges from 300 to 3,000 trees an acre. It's incredibly dense, especially in the areas that were seeded. And so that was that change in public opinion was really instrumental in bringing it towards what we now know as Redwood Rising. The other parts is that this initial restoration was given money by Congress when they expanded the park, but that money was running out. They did not have an infinite pot of money, and it is really, really expensive work. They were wanting to work on more of the forest treatments, and they kind of had put it together that if you take out the roads, it makes it very difficult to be able to go back in and do any sort of forest thinning. And so they realized that those things needed to go hand in hand. The park had an additional expansion of the Mill Creek property up in, I believe it was 2012. And so that was purchased by the Park Service and through Save the Redwoods League. So they had this large additional area that they wanted to work on restoring. And so I think this is something I had just learned working for the park, but they decided to do something that they hadn't really seen done. For the most part, when you're looking at a restoration project, you have an idea, you have a proposal, you try to get funding, and then you use that initial funding to really do the official plans and things of the project, because so much work goes into the permitting and planning for these projects. But what they did instead was they focused on using just their rather limited state and national park budgets, along with Save the Redwoods League, before they had any real funding, they began on really working on getting all of the planning done, all of the permitting done, putting timelines together, all their justifications and science to this restoration project. And then they took that to funders once it was considered shovel ready. And you'll see like more and more projects are working on that or using that kind of model. But at least people at the park really tout it as like one of their big successes was, instead of continuing to try to get money for a project that wasn't fully formed yet, getting the project fully ready and then working on getting money. And once that was all set, they really formed the official partnership. So Redwood Rising refers to the partnership between California State Parks, the National Park Service, and Save the Redwoods League. And Save the Redwoods League has been really huge in securing and managing all of the funds for this project. And so that brings us to Redwood Rising as we know it today. For those of you who are more familiar with the area, I think this is just a really great photo. So I just wanted to point out that this is where Redwood Creek is coming into Oric. And then this is where there's that big Oru restoration just outside of Oric. We've seen some pictures of it in class. This is called Berry Glen up through here. This is the Davidson Meadows, and if you've ever gone to Fern Canyon, you've driven this road here out to Fern Canyon. And all of this over here would be considered part of the Prairie Creek watershed. Prairie Creek is a tributary of Redwood Creek that joins just up here at the Prairie Creek confluence. So Redwood Rising is a very big project. The goal is to have a full watershed restoration program. And so the goal is to rehabilitate over 70,000 acres of second growth forest in Redwood National and State Parks. And so a big focus of that is that forest thinning, alongside removing 300 miles of abandoned, failing, and inaccessible logging roads. And that's really where the stream and the watershed part of it comes into play. There are specific things listed for the stream restoration component is to restore healthy streams and rivers in Redwood National and State Parks, protect aquatic habitats, and improve water quality by addressing issues of past logging. And that water quality issue is really with turbidity and that movement of suspended sediment. And so their key objectives to meet those are by daylighting buried streams, reestablishing the natural stream flow and hill slope hydrology, and providing better habitat for salmonids. But it is not listed anywhere that I've seen as one of the official goals of increasing any sort of salmon population. The listed goals are really focused on those habitat metrics and meeting Congress's watershed rehabilitation requirements. So the project area is split into two main work zones. Greater Mill Creek, which is up north near Crescent City, up in this area. That hatched zone is all of the Mill Creek zone. And then the Greater Prairie Creek restoration area, which is down here in this hatched area. So I will be talking about both of them, but my main focus is going to be on Prairie Creek. That's where all of my thesis work has been. That's where I really know the most. But a lot of the metrics that, a lot of the summaries and things that they put out in terms of money or miles of roads removed are all summarized across both basins. So I'll talk a little bit about both of them, but my main focus will be on this southern section, the Greater Prairie Creek watershed. The timeline for the full project is over 30 years, and that was starting in 2019. As I said, the first two areas to be addressed are Mill Creek and Prairie Creek, with them expecting it to take that full 30 years to address the different projects in Mill Creek, and 10 to 15 years to finish all of the planned work within Prairie Creek. Beyond that, there is still a lot of work to do, especially within the Redwood Creek Basin, mainly in the thinning aspect of Redwood Creek, but that'll be is not currently planned or funded. So far, there has been a lot of funding. It costs an average of $18 million a year to do the actual restoration, and that includes everything, contract staff, overhead travel, everything. And that's for both Prairie Creek and Mill Creek together. And there's been, since 2020, almost $5.5 million spent on monitoring and compliance alone. And that's, as I understand it, a pretty unheard of amount of money to spend on monitoring. A lot of those compliance parts of it are monitoring for legal compliance, but just it is a very well-funded project in terms of monitoring. This figure on the other side was put together by Save the Redwoods League, and this is the total amount of money raised to date. Again, they're trying to get to that 30-year mark, and so a lot of it is federal and state funding, but I did want to point out that part of the funding, which I think is just cool, is when they do the thinning, when it's accessible and reasonable, they sell that wood and they put that money back into being able to do more restoration. And so it's one of the few restoration projects that is partially self-funded. So the Mill Creek Basin generally is a really rocky and hard geology. You have a lot of big boulders and very steep slopes just from that underlying geology. Mill Creek also generally has a lot bigger streams. It's hard to imagine that you would get much more rain than you would in Prairie Creek, but they do. And so overall, you see fewer things like Humboldt crossings because there's just too much water, and you also see a lot less dense roads. That's for two reasons. For one, it's just harder to build roads when the rock is really hard, and so they relied on different types of forest practices. But also, Greater Mill Creek was harvested up until the early 2000s, and so a big portion of it being managed as private logging was since the California Forest Practice Rules, and so it was generally left in better conditions in terms of the volume and condition of roads when it became a part of the park in comparison to Prairie Creek. And they also, a big thing is that they used a lot of cable yarding, and so that allows them to pull the trees up the slopes instead of dragging them down and across the slopes, which is what was done in Prairie Creek. I'm not going to go into it beyond this slide, but Mill Creek has a lot of very cool restoration projects going on. There's a lot of large wood installation. We talked about that a bunch in this class. Different work to try to reconnect the floodplain, especially of the main stem Mill Creek reaches. They are doing road removal and helping to restore that hill slope hydrology along with forest thinning like the rest of Redwoods Rising. And then there's been a couple just kind of cool projects to replace a bridge, move it to a place that was had less key habitat, taking out culverts, opening up fish passage, but there was not any daylighting in this section. Where Prairie Creek is kind of a whole different story. It had very, very soft geology. The underlying geology was all old sediments from the Klamath River basin, from the Klamath River, like millions of years ago. But that means that what we have is this very soft sedimentary rock with a lot of serpentinite clay. And so it's very easy dirt to move. And so that means two things. The first is that you have a lot more roads. They would build a road to practically every single tree because the trees are very big. And so you have these networks of haul roads splitting off into smaller spurs and then having just a ton of skid trails because they would tractor yard out pretty much all of these trees. So you have very, very soft roads, and then that means when you have soft geology and a ton of roads, you have a ton of opportunity for erosion. And so that leads to kind of one of two main conditions. So we have a lot of Humboldt crossings on top of that. So that's where you have logs that are just piled into the stream channel, sediments put on top and just driven over until it becomes stable. And so when you have all this soft geology coming down into a Humboldt crossing, it has kind of one of two conditions. It either has a lot of sediment plug up that Humboldt crossing and then begin to build up and up and up to the next Humboldt crossing. So what you end up with is this buried stream channel that is anywhere from 5 to 20 feet of sediment and debris on top of it. Or if you have a big enough stream, you end up having all of that blow out in a big landslide where you have a ton of sediment pollution in those downstream tributaries where we really have a lot of salmon. And so this was all clear cut before the 64 flood. And so when those floodwaters came, we saw really one of those two things happen at almost every Humboldt crossing. And so there are a lot of buried stream channels. So the Prairie Creek restoration does include some of those similar projects to Mill Creek. There are some riparian planting projects, large wood installations in Prairie Creek itself, but a big focus of the Redwood Rising side of things is on removing roads to restore that hill slope hydrology and those natural processes, and daylighting channels that have been buried due to failing hill slope hydrology. So I included these pictures because I think it can be super difficult to understand what we mean by a buried stream channel. Because a lot of the time it can look just like the forest floor. So over here you can see this is actually looking downstream in one of our reaches, and outside of seeing this hill come down on this other side and knowing that you had water above and below, you would have no idea that there was a stream here at all. Here you can see that there's this eroding crack from water trying to weasel its way through that's starting to tip these trees over, but otherwise there's really no evidence of the stream. But then in other cases, you'll have what looks like a nice small creek, like over here, where we can see the stream gravels and um, there's clearly flowing water. It's not just seeping through groundwater, but up above it, you see this long section that's really unrecognizable as a stream. You can really lose the channel. And then as you move, in this particular case, about 70 meters upstream, you start to see creek again. And one of the interesting things is that we actually have fish up past this, so we know that it's not functioning entirely as a stream barrier, and yet we have really no identifiable channel because it's just so buried. And then here we see a different stream which has kind of different buried conditions. And so here it was a combination of a lot of sediment, but also a lot of logging slash. When they would delimb all these trees, they just toss it all into the stream channel. So you end up with these small streams that are just very choked out in this kind of lasagna of sediment and limbs and other types of logging debris. And so all of these are, technically looking at a stream, but it's really hardly identifiable as any sort of aquatic system. And then this is what it looks like when it's all daylighted. These are 3 after photos looking at different years of restoration. But in a lot of ways, it can kind of look like a bomb went off. Here, this whole hill slope has had its riparian vegetation removed and a bunch of logs put down to stabilize the hills. But we have a lot more of this, what looks like a creek. We have perennial surface flows. We have fish. It's just a very different system. And so how do we get from a buried stream to a daylighted one? How it is all designed is by road shed. So I described a little earlier how you have a haul road with these different short spurs coming off and then lots of skid roads associated. And so all of the brown in this map are all logging roads. And so what they do is they map out the roads and they figure out how to get all the way into the very back sections of these units, all the way at the top of the roads. They open up the roads so that they can bring through logging equipment and do that variable density thinning. And then once the logging is done, they systematically remove the roads from the back to the front. And then whenever they come into a place where there is a Humboldt crossing, they'll work on taking that crossing out and then daylighting the associated buried sections with that crossing. And so in this map, it's a little difficult to see, but each of these polygons, these different colored polygons, are different road sheds. And then each of the colored sections of the streams are areas of the streams that have been daylighted. So in some sections, it's pretty short because it was really mostly just that crossing that had to come out. And in other areas, it's the majority of the valley bottom because it was so severely buried. Unlike a lot of projects, and some of them that we've heard of in this class, this is not at all an engineered project. There are not any engineering plans that go into daylighting. What they really rely on are clues on the landscape, and for the most part, a lot of those clues are buried, and so it's really difficult to try to plan out where things will go until you get started. And so one of the main things that they'll try to cue in on are where there are existing old growth stumps. So both these pictures are from the same stream, and you can see where all these red arrows are. You have this pattern of different old growth stumps, and so we know that that was approximately where that hill slope would have been because we know about the height that they would cut the stumps and that if there was an old growth stump there, then there was a tree there. And so a lot of the time these are actually fully buried by the time we're getting out there, both from decades of erosion and because they would actually just cut the tree down, put the road over on top of the old stump to get further back. And so they'll rely heavily on stumps. They'll also look for stream gravels. That can be difficult because all of this sediment was from the Klamath, and so you have these rounded river rocks all over. But where we see these clean layers of river rock, they'll cue into that to try to get an idea of what the original stream gradient was. And then whenever possible, when they can identify the topsoil, they do their very best to get that on top so that all of that existing seed bank will be more likely to germinate, and it also helps them to just cue into where that natural hill slope was. And so this is what it looks like kind of in mid-progress. You can see there's the stump up on the side over here, and they're starting to place some logs to stabilize through here. But really, we just have an equipment operator who is really skilled and working with different National Park Service staff or state park staff if you're in Mill Creek to cue into these cues on the landscape and to recreate these valley bottoms, which is a pretty massive disturbance on the landscape. Here's a series of photos that I like as a pretty good before and after. So here, if you kind of look at this stick here, this is a picture of the road once it's been reopened up to get that logging equipment in, and then they're just about to start removal at this crossing. You can actually see the sticks sticking out from the old Humboldt crossing. Here is that same stick right here, and this was immediately after. There was some funky geology here. There was a very, very old, way predating logging landslide at this spot, so that's why we have these large boulders in the middle. That's not typical. But then over here, we can see that those boulders have really weathered in the 5 years post-restoration. If you look at this stick here, you can see what that looks like 5 years later. So it really does come back and stabilize well with vegetation within a couple of years. And just for some scale, right here in the orange is actually one of my apprentices from when I took this photo, just to kind of give an idea of just how much sediment is getting moved out of these systems. It is truckloads and truckloads and truckloads of sediment. So to date, there's been a lot of progress. These are summarizing both Prairie Creek and Mill Creek, but there's been 21,000 feet of channel daylighted, and that's all within Prairie Creek. There isn't any daylighting in Mill Creek. The forest restoration treatment, all of that thinning, is covered almost 4,000 acres. There's been 32 miles of roads removed and an additional 28 miles of roads that have been improved. Those are mostly up in Mill Creek, where, again, we have those roads that were in better condition to start with. And then there have been 59 culverts and crossings, so that includes Humboldt crossings as well, that have been replaced with ones with good fish passage or removed altogether. So for the assessment, most of it is still ongoing. This project is still in progress, but one of the main parts of the assessment is in the understanding how this is impacting sediment. That's really the main purpose of the project, and so that is there's continuous hydrology monitoring. There's 4 different gauging stations in the park that are continuously monitoring the discharge and turbidity, along with collecting suspended sediment samples so that we can understand how much suspended sediment is moving through the watershed per year. And so there's 2 of these that are looking at areas that had road removal back in the 2010s, and those have seen a significant reduction in suspended sediment post road removal. And then there's 1 station focused just on the current restoration areas. So there's kind of 2 main things we want to look at with that. We want to understand first if we're overall reducing the amount of suspended sediment by removing roads, and from our longer term studies they've been able to show that. But the second is to understand how much putting this large equipment in all of these small streams is impacting water quality downstream, and that sort of analysis I don't think has been fully completed yet. It's definitely still ongoing. I know one of the difficult parts with that is it's on, the stream is called North Fork Strelo, and there's been continuous work in that watershed for several years now. So it's kind of hard to pinpoint how soon after 1 year of restoration does that particular project stop producing fine sediment. But it is one of the questions that the park monitors really closely. The second is looking at how these daylighted sections respond after being excavated. And that's the topic of my thesis. There are some great looking results so far. I've been able to show a reduction in overall fine sediment, an increase in habitat available to salmonids, increase in presence within these sites, but that is still very much ongoing. If you want to come and see my defense in May, you could probably hear a lot more about it. There's also a really big component of the study that I'm not going to be able to address in my own thesis, but that's really trying to get a better idea of what's going on in these buried channels. A lot of what we do to measure a stream you can't measure when it's buried, but where we are able to get a little bit of water, we can do eDNA and get a better idea of what areas still maintain fish connectivity, how alive these systems really are, if they are as degraded as they might appear from someone who can't see it while it's buried. And so that's a project that will hopefully have some good results coming in the next couple years. And then for that watershed scale and really looking at potential impacts to fish populations as a whole, Darren actually has a crew ran by Kate Stonecipher that's monitoring coho populations within the Prairie Creek watershed as a whole. And so that looks at a lot of different restoration and overall looking to see if there is an increase at that population scale. And so that also has results pending, but they run a screw trap to get all of the out-migrating salmonids. They do snorkel surveys, seining, pit tagging. They have several pit tag antennas to track movement. So there's a lot of effort to really get a good grip as to how this scale of restoration is impacting populations. And then, as I understand it, that study is actually going to be expanded to look at cutthroat as well. So it'll be cool to get that basin scale information on top of, like, my project is very site specific. So there is a lot of different assessments going on, and as I said, there's over $5 million that have been spent so far on assessment. So that's really what I have for today. I hope you guys enjoyed. I'm always happy to answer questions. I love talking about this. I've spent a lot of years on it. And yeah, I hope you enjoyed. Here's just my citations. Thank you.